Yeah, I was explaining evaporative cooling because that I guarantee you're going to be asked about it because it is the hottest topic right now. And so what happens is, and if you go to Danfoss, they are a pump company. They sell those things like for evaporative cooling, and so they explain it way better. So go to Danfoss and watch a video from those guys. They explain it and show you way better example. I was asked in an interview, or one of the interviews in Sweden, about evaporative cooling, and I was given a week to do a research about it. Trust me, I could not find anything that was relevant. That's how tough it is to find things about evaporative cooling. But I'm here as well to discuss if you guys want to know more about it. But it's basically, it's very easy. It's very easy. So either they are taking that air using air handling unit through the data center, and they have just a small pump. So the main three components are just the filter to filter the moisture, and there's a pump, water pump, that is being used to spray water into the air, and there's a what else? Yeah, basically that's it. You see, it has way less components, but the only disadvantage about it is it promotes. You need to know the main disadvantage. It promotes. It's difficult to really filter all the moisture out of the air. So sometimes you may need a dehumidifier to try and dehumidify the air. And in most cases, a lot of water is getting dumped in the air. So there's too much. You're going to have a problem with humidity. That's one of the main disadvantages for it. That's the reason why they advance it now to the adiabatic one, which is more of a foil, and the air doesn't really get mixed. So they just cool down. They use it to cool down, like what we do in the cooling tower. The cooling tower actually is the reason why the adiabatic cooling was developed. Because remember, we said the cooling tower does. So I didn't really explain the cooling towers. So at the cooling tower, what happens on the water is the water is coming back from the condenser, right? It's coming from the condenser, that is warm water, right? With a pipe, which will be on top. Most of the time, it's always on top. And there's a fan on top, right? To suck the air up, or sometimes it can be at the bottom to push the air up, right? So as the water is getting dropped, and there's fins, through fins, and evaporation start taking place, right? Because remember, we say there's a fan that is there, and it's on the outside, and sometimes it's a hot day, so there's evaporation that is happening, taking the air up and leaving that cooler effect that we spoke about when you put a hand on top of something. So there's some advanced insulation that they're doing now to try and retain the water. So the main disadvantage of cooling towers is there's a lot of evaporation taking place, and you are losing a lot of water. That's why they're discarding that. You're losing a lot of water because the water gets sprayed onto the fins, and the evaporation starts taking place, and the air starts. So some of the water that will drop right to the ground and into the smaller tank at the bottom and gets taken to the back to the condenser. That's how it cools down. So there is evaporative cooling happening there. So that's exactly how they manage to make adiabatic cooling, because it's just a replica. Just that water, right? That is evaporation happening, and there's fins. That's how it takes the water, and that water goes. I'm sure it's a refrigerant, or it can be water as well that goes in there as in a coil, and it's a cold. Now it becomes a cold water, right? Just same like the cycle of a condenser. Then the cooling fan will just on the other side of the condenser, you just blowing air through into data center. So there it's an advantage because there's no direct contact with water and the air that is going through. But it's a bit of a complex thing. So I'm trying to and make it as simple as I can so that I won't chase away a lot of guys. So because you won't really fix anything, but you need to know. And the disadvantages for cooling tower, we say they get dirty easy because they're outside. Corrosion happens a lot. They need regular maintenance, regular cleaning, and the water gets dirty because it's exposed to the elements. And the biggest one is you lose a lot of water through evaporation because it's assisted evaporation, since there's fans that are really blowing on top or upwards or downwards, depending on the design, through the water. So it's assisting in cooling, yes, of course, but it's also assisting in too much sped up evaporation of the water. So that's adiabatic. So some guys may just say adiabatic and evaporative cooling is one and the same thing, but they are a little bit different, but it's the same principle, right? So it's the cheapest, one of the cheapest ways, was, remember in the deserts we say the heat is for free. So the fins get hot, and once the air is sprayed, the water is sprayed on top of the fins, evaporation starts taking place, and voila, cooling effect happens, and they take that cooling effect right into the data center. That's how they make it very, very, very easy now for data centers to mushroom in the Arabic countries. So I'm going just to repeat a bit about chillers. I feel like there's a video that got lost before yesterday about chillers. So I'm going to repeat a little bit about chillers. So chillers, everyone still remembers the direct expansion, right? Direct expansion, the DX system, which is the refrigeration cycle, it's one thing. It's all one thing, the simple one. So chillers, remember, it always have 3 circuits. There's the circuit of water for the condenser side, right? Condenser side, the one that we said it can dump air using what we just explained now via the cooling tower, right? Water gets from the condenser up on the cooling tower, drop the ground, then pump. So there's a pump maintenance for that. The reason why I'm talking about this is because you need to know the maintenance part about it. Besides the cleaning, so there's a pump involved, right? Not just one, you need a bit two. So there's one that is running normally, and the other one which is on N+1. It's always an N+1 or N+2, depending on the system, or 2N+1. Remember, we spoke of redundancy before. It gets applied a lot in every part of the data center because you have only one fan or one motor, one pump, right, that is pumping the water to the chilling tower from the condenser, and it fails, you're in serious trouble because the data center will get warm and you get sued by your client. So that's why they have these pumps, which are run on cycle mode and cycle and duty mode, and they will have N+1, N+2, 2N, whatever design they do. And that's the way they lose most of the money, but they don't really worry because most of the time one fan that is one motor, one pump that is running, pumping the water on the outside. So when you get to do maintenance as well, you can just bypass one and replace bearings or whatever, and they monitor those motors by BMS, right? So I had to put it out there. And the second, number 2, is the direct expansion, which is the in-between, the go-between of the two. So if I'm to make it in cycle mode, you try and draw something better, which is in cycle. So it will be condenser, DX, and evaporator. So I think this is the simplest thing, simplest way to explain it. So you have a DX circuit, which is the normal refrigeration cycle that happens here to take heat from the evaporator, right? chiller evaporator. 2, dumping it to the condenser, right? Dumping the heat to the condenser side, and we get again the cooler water. When it's dumped here, it goes again back. Then we take again, we dump our coldness, we get it back, we get the heat. So 2 effects. So here it's at the bottom, dumping it, at the top, taking cooler water. Here, taking cooler coldness. No, it's not taking cooler water, it's taking the coldness from the water, because this water here never mix with the refrigerant here in between. And here it takes also again. So this is, I guess this is the simplest. You're not going to find this one anywhere else, but this is the simplest way of explaining a chiller. It dumps here the coldness to the evaporator. Evaporator takes the air into the building and brings takes there's water as well. So this, for a chiller, this always is, it's water. It's always, that's why it's called chilled water chiller. Takes the water into the building and brings back a bit warm water, dumps the heat into the DX. The DX takes it out. So it's always a cycle. So I guess this is the best way to explain it. And yeah, I think I finally got it. This is how you best explain the chiller. So the evaporator, there's special water, right? The evaporator for a chiller. There's special water. This water gets, you don't really lose much of it, but I'm sure the guys that have done massive industrial HVAC systems, they know how to maintain this. So we need to check on the maintenance. It has also its own pumps, right? It has its own pumps as well, similar to the condenser side. It also has its own pumps where you got to also on the N+1 or N+2 scenario, and you get, and here also on the DX system as well. Sometimes these guys also may have as well, not just 1 compressor, but probably 2 compressors or 3 compressors, depending on the size of the system. But compressors here are quite big. So you can check some of the basic stuff on it, which is for free on Engineering Mindset, but always remember the summary I've just explained for you here for all this stuff. Yeah, I was just checking if I was recording. I was gonna beat myself today. Yeah, so basically, that's it about the refrigeration. And for those who can be able to attend courses about it, please do, and always revert back to the pointers, because me, I'm giving you pointers. I've done a lot of interviews, a lot of interviews on data centers. Yeah, so you know all this stuff. You got to, I just gave you pointers on what you really need to know about this. And so the evaporator is not really exposed to the weather and stuff. The only maintenance that needs the evaporator is just to check the water if it's still the same level, because it never gets lost anyway. There's no evaporation that takes place here, other than the evaporation of the water inside. It never goes anywhere. It's always in there, but it gets checked for its quality, and if it reduces the amount, right, for any other reason, or there's a leaking pipe or anything. Those are the only things that gets to be checked on the evaporator. DX system, like I said, it's always, that one gets checked a lot of times. Like normal fridge pipes, all right, the refrigerant is still good quality, all those things. No oil in the pumps, no water in the pumps, no too much oil in the pump as well, because sometimes the refrigerant may gain water. I'm sure the refrigerant can We know that. The condenser side is the main part, right? So you get to be asked the question to say, hey, you find out that there's no cooling happening in your data center, or your temperature is not lowering. How best can you fix it? So you have to be able to explain this. Like I said, the better you explain it, the better you simplify it even for the interviewer, the higher your score will be, the higher your level of tendering will be as well. There's different levels to both things. Yeah. And basically, guys, that's it about chillers, air handling units, and humidity, temperature. So all this stuff is being done only to make sure that we have the right humidity and the right temperature. Always remember that. Going into our equipment, high humidity affects us in what? In what way? High humidity means a lot of water in the air, and we are trying by all means to avoid the dew point, because stuff gets to get wet and we lose our very expensive equipment. Yeah, there are other ways of cooling data centers, which is the new way now. They call it the liquid cooling, but you don't really have to worry about it. For those who have interest, can go and research about it, but that's more special cooling, which I don't think is real, but you may just know about it. But liquid cooling, they are actually using special kind of water, and they have special kind of equipment which is directly sunk in there. So servers actually dipped in the water. Yeah, I've not seen it with my own eyes yet. All data centers that I went to, that I'm going to, which are being constructed as recently as last year, no one. Yes, that's still an internet thing, still things for show off. But with the world growing as it is growing, you will definitely see things like that gathering pace because of the AI spoke about. So it's you now, as in you need to be able to explain how you save PUE, right? Because that's the only way you save money for your client. You get to be hired. Not everyone may be hired in a big data center, but I guarantee you, if you can explain all these things, you get to get hired by any smaller company data centers, probably 5 staff or whatever. And if you know most of this information, you may help your client improve or your boss improve his PUE or become competitive in the market. So I guess that's all for now. And guys, do you have any questions? I think I have a few minutes. I can attend to any questions that any one of you may have. Yeah, so if there are no questions, next week we're gonna try, and we have to do fire systems, right? Most electricians have seen it before, and some of you have wired it before, but it's a very, very important subject, the fire system, because fires are, with this global warming, they are happening everywhere. Heat is our problem. As you can see, everywhere we are trying to fight heat, so there's high risk of fire. Some may start from inside, some may start from outside, and it's our duty to try and detect it earlier than anyone else so that we can fix this issue, right? So fire is security. So with fire, I've already spoken about BMS in a lot of places. So you can be asked, how to use it? Where does the BMS apply in the data center? So we've already explained most of the things that are being monitored. So remember, a BMS doesn't control, just monitors, the monitoring system. never controls anything, just alerts you. So instead of having 5 guys, one looking at the UPS, one looking at the generator every 10 or every hour, you have a BMS system which will be monitoring your fuel levels, which will be monitoring your run hours on the generator and be displaying to you, and at the same time monitoring the UPS battery, monitoring the UPS, what mode is it operating in. Already covered UPS, but you guys are free to tell me whenever you have an issue or some topic that you want us to repeat. We can repeat it quickly, and if we have an issue on the big topic, which is refrigeration, cooling, yeah, that's the big one that's get monitored a lot by BMS, because the BMS now will tell you if I'm running in free cooling mode or I'm running in how much power I'm using, and if it's heating mode or it's cooling mode. You have to know all those, and is the BMS which will tell you. So you get to not really fix it, depending on the program that you are using. I'm not going to mention a lot of programs here because the copyrights and stuff. So I won't mention anything of that. But depending on the program, how smart it is, you can be able to monitor almost every aspect in the data center using the BMS. So that's it, guys. Let's discuss fire next time. Thank you, guys.